Hey class, hope you're all doing well. So today's going to be an exciting day for us. We're nearing some of my favorite material in calculus, just flat out across the board. This is involving what are called power series, which we'll dive into today, eventually Taylor series, and how we can represent functions we know and love using infinite series expansions. Today we're going to talk about that first piece, which are called power series. So first, we'll dive into what we've been talking about in class, and then finally give the big picture for today. Check it out. So where we're coming from in the last couple days of class is we've been thinking about convergence and divergence tests for infinite series for a couple weeks now. In particular, we developed tests to see if a series that only has positive terms, if it's convergent. And these were where the comparison test and the integral test kind of came into play for us here. Next, we started thinking about what happens if those series start having some positive and negative terms. And we saw that, well, if a series has an alternation in sign, plus, minus, plus, minus, plus, minus, it is actually what's called an alternating series. And we have a test to help us out with those, the so-called alternating series test. And lastly, what we spent a little bit of time discussing was, well, what happens if this series has both positive and negative terms, but there's no discernible pattern in which there are positive terms and negative terms and so on. And this is where we started thinking about ideas like absolute convergence, basically saying, hey, if a series is absolutely convergent, any assortment of negative signs sprinkled within that series will also result in a convergent series. So in particular, the series test we had for testing whether or not a series is absolutely convergent, as long as the series had one of these three key types of terms, namely numbers raised to powers of n, numbers that are not 1 or -1, n factorials or n to the n type terms, we had at our disposal the so-called ratio tests. And the ratio test is going to help us out actually today with power series when we start asking this ourselves, well, if we have a power series, what values of x are we actually allowed to put into our so-called power series? All of that might seem a little cryptic because we haven't even defined what a power series is yet. So let's go over what we talk about today. So the big picture of what we're going to talk about is generally everything is centered around this idea of what a power series is. Without getting into it too much, we can think of a power series basically as an infinite series, except an infinite series in which we now think of it as a function of x. So for example, here is an example of a power series where we have some function of the variable x equals an infinite series expansion in which x is showing up inside of that series or in each term of that series. So the question is, what value of x are we actually allowed to put into these things, as well as what's the value getting passed back? And we're thinking about these things as functions. So we'll discuss today that we can actually integrate or differentiate these two things or these types of power series, as well as the big question that we're going to hit today is if they actually are functions, what values of x are we actually allowed to evaluate our power series at? That's basically asking the question, what is their domain? And the nice thing for us is this is where our friend, the ratio test, is really going to help us narrow down negative infinity to infinity as possible x values to put into that series and narrowing it down to a more specified region. Lastly, what we're going to start asking the question is, well, if these power series actually are functions, what functions could they be? And we're going to first investigate this idea using our friend, the geometric series, to give us the power series for one particular function. That's the function 1 over 1 minus x. And then we're going to do a lot of analysis using this function to find basically power series that are similar or for similar functions to that 1 over 1 minus x, and show how we can differentiate or integrate this power series as well to get other similar power series representations of functions. So today we're focusing on really the key aspects of what is a power series. If they're functions, what can we do to them? What actual x values are we allowed to evaluate them at? What is their domain? And then we're going to start asking a question of what functions are these power series actually representing? And we're going to mostly focus our efforts on basically different slight variations of this function 1 over 1 minus x. So that's what we're going to do today. Please check out the videos attached. See you in class soon.